have 25 centimeters cubed vinegar sample. That's a volume. That's our volume of vinegar. So let's separate that out, 25 centimeters cubed of vinegar being neutralized by 45 centimeters cubed of KOH solution of a concentration 0.4 moles per decimeters cubed. So we have two chemicals here, something to do with vinegar and something to do with KOH. The question wants us to calculate the concentration in moles per decimeters cubed of the CH3COH, this acetic acid, in this sample of vinegar. So we need to work out the concentration of acetic acid in the vinegar, okay, belonging to that vinegar. Now the first step is to know what we're dealing with. Which formula are you going to use for this question? You may want to draw your triangle out if you are using triangles to help you through these calculations. Okay, so I'm drawing a roughly drawn triangle here. Concentration, number of moles, and volume. How do I know I'm using this triangle? Because I have a volume, centimeters cubed, I have a concentration, moles per decimeters cubed, I must be dealing with this triangle. The second step will be to work out and start using the numbers. I always look for which chemical, between the vinegar and the KOH, which chemical has two numbers associated with it that I can use. Well, in this case, the potassium hydroxide has this volume and this concentration. So I have a concentration and a volume for the KOH. So I can work out the number of moles of KOH with my volume and concentration. So I will do 45, first of all, divided by 1,000. Why will I do that? Because my 45 is in centimeters cubed. If you ever see something in centimeters cubed, you want to convert it to decimeters cubed first. And to do that, you have to divide by 1,000. Never keep it in centimeters cubed. If I divide it by 1,000, that will give me 0.045 decimeters cubed. And that's what I want, okay? So that's my volume. I've also got 0.4 moles per decimeters cubed. So you can see I've got my decimeters cubed all lined up and ready to go. So I have my volume and I have my concentration. What do I need to do? Concentration times by volume to work out my number of moles. So my number of moles of KOH equals 0.045 decimeters cubed times by 0.4 moles per decimeters cubed. And if I tap that into a calculator, I'll find out that is 0.018 moles of KOH. So I've worked out already, I'll underline it to show it's important, 0.018 moles of KOH. Now, this is where the next step is quite important for step 3, is I need to go back to my equation and see the ratio of the number of moles. Now, I don't have any numbers in front of this, so that's going to be a 1 mole. There's no numbers in front of KOH, so it's 1 mole of this, 1 mole of this, and 1 mole. So it's all 1 to 1 to 1 to 1 ratio, which is really useful. That's very easy to calculate now, because that means whatever my number of moles are for KOH will be the number of moles for my acetic acid here. So those are exactly the same number of moles. So for step 3, I know my number of moles of acetic acid, CH3COOH, is going to equal 0.018 moles, because the number of moles will be exactly the same if it's a 1 to 1 ratio. So it's 0.018 as I worked out before. So I've got my number of moles of acetic acid. What could I do with that next? Well, I've got my moles, and in the question, if I go back up to the question, I can see it said 25 centimeters cubed. So I have the volume and I have the number of moles. Well, if I go back to my triangle for acetic acid, I have concentration, number of moles, volume. I know I have my number of moles and I have my volume. My volume, remember, is in centimeters cubed. Let's turn that into decimeters cubed. So let's divide that by 1,000. So it'll be 0.025 decimeters cubed. So I'm going to do My number of moles, 0.018 moles, divided by 0.025 decimeters cubed. And that will give me my concentration. And if you put that into a calculator, you'll find that it is 0.72 moles per decimeters cubed. And that is my final answer to that question. So that's the answer to a more straightforward question. Now let's take a look at a slightly more complex, but exactly the same method situation here. My first step again is I'm going to read the question, and I can see that I have 16.7 centimeters cubed, and I've got some concentrations here. So my first question is, what am I doing here? Well, if I have volumes and I have concentrations and I have moles, I'm going to draw myself out my triangle. It's a bit of a rough triangle. Apologies about that. Concentration, number of moles, and my volume there. Okay, I'm dealing with that triangle. That's what I'm using, that formula. Okay, so we're thinking formula. My second step will be to work out what belongs to what. So in this question, I have 16.7 centimeters cubed of sulfuric acid. We'll be neutralizing my second chemical, 25 centimeters cubed of sodium hydroxide, which has a concentration of 0.2 moles per decimeters cubed. They want me to work out the concentration of the sulfuric acid. Okay, so I've got my two numbers here. That's what I'm going to do first. I'm going to start dealing with my sodium hydroxide first. Let's do that. So my 25 centimeters cubed, I don't want it in centimeters cubed. I'm going to divide that by 1,000. Okay, 0.025 decimeters cubed. I've also got a concentration, so that's my volume. Let's work out my concentration. My concentration is 0.2, nothing to work out. They've already given it to me. Moles per decimeters cubed. So I have my volume and I have my concentration, so I can work out the number of moles of NaOH. So my number of moles of NaOH will be equal to 0.025 times by 0.2 moles per decimeters cubed. And that will give me my number of moles, and that will be 0.005 moles. And again, I'm going to underline that to show you how important that number is. Now remember, my third step, once I've worked out my moles, I'm going to go back to my equation and see the mole ratio. Let's have a look to study this equation. Now I've got two sodium hydroxides here to a ratio of 1 sulfuric acid here. I've got one product and I've got two waters. So this number of moles that I've worked out here for sodium hydroxide is actually 2 lots of moles. They want me to work out for sulfuric acid, and I've only got 1 lot. So when I start calculating for sulfuric acid just below here, and that's what I'm going to do now. Once I start working out for sulfuric acid here, my number of moles of sulfuric acid is actually not going to be the same as before, because it's not 1-to-1 ratio. I have to divide that number by 2 because that was for 2 lots of moles. I need it for 1 lot of mole, so it's actually going to be this number of moles, 0.0025 moles for H2SO4. What else do I know about my H2SO4? Well, I have 16.7 centimeters cubed. 16.7 centimeters cubed. So my volume is actually 16.7 centimeters cubed. I don't like that number because I want it in decimeters cubed, so I'll divide that by 1,000 to give me 0.0167 decimeters cubed. Okay. Now again, I'm actually going to come back and I'm going to draw my triangle out again for H2SO4. My really rough triangle. So my concentration, my number of moles, and my volume. What do I have here? I have my number of moles and my volume. I can work out my concentration as the question wanted me to. So my concentration will be equal to 0.0025 moles divided by 0.0167 decimeters cubed. And that will give me 0.150 moles per decimeter cubed. And that will be my final answer. That is my concentration of sulfuric acid. Going back to the original question then, just make sure you are careful that you check your mole ratio. We had a 2-to-1, so the number of moles of sodium hydroxide we worked out was double what we needed, so we had to divide it by 2 in this step just here. And that is how you work out the slightly more complex titration calculations, using the same method but being careful with molar ratio.